Hi, boys and girls. Can you guess where I am right now? That's right. I've been sneaking into our classroom all last week and starting this week just because I find I'm able to focus a lot more without my kids running around. So luckily today it's so beautiful. My parents called and said, let's take Kate and Addie out on an adventure. And I'm like, perfect. I have so much I need to do in the classroom. So I wanted to touch base though and go over geometry because I know I started you on module 4, and since we're not here together to go over questions and things, I wanted to take a little bit of your time just to go over some parts that may be confusing. And that way you have the groundwork for being successful in geometry in the future, okay? So we're going to take a look at the posters here, starting with lines and more. So we all know a point, an exact location in a space. So that is a lot of times what we use on a number line to precisely place data. Now, a line, you notice has arrows, okay, on both ends. It extends indefinitely in both directions, meaning it never ends. That's why we signify it with 2 arrows. A line segment, on the other hand, has 2 endpoints. It's just a portion or a segment of a line. Okay, so it has 2 endpoints. A ray, it begins at a fixed point, but it extends indefinitely in the other direction. An array can face either way. Okay, angles are made up of rays. They have the endpoint and they share the endpoint, which shows that the lines then continue on in those directions. Okay, so line never ends. Line segment is just a section of the line, 2 endpoints, and the ray endpoint with the arrow. Okay, parallel lines. They are lines that never intersect. They never ever touch. If you continue drawing those lines forever, at no point would they ever intersect. Which then leads me to perpendicular. Okay, these are 2 lines that also intersect, but where they intersect forms 4 right angles or for 90 degrees, which is why we have those boxes there to signal those 90-degree angles. Intersecting lines are just like they sound. They are lines that intersect. They have 1 point in common. Now, it's important to note that perpendicular lines are also considered intersecting lines because they intersect at a point. However, not all perpendicular lines are, not all intersecting lines are perpendicular. So, the way I try to remember those different lines is we have parallel, never ever touch, perpendicular, 90 degrees, intersecting, lines that cross. So if you want to do that jingle just to remember, parallel, never ever touch, perpendicular, 90 degrees, intersecting, lines that cross. Okay, so moving on, you then were talking about angles. Okay, so we know angles now have an endpoint and 2 rays. Angles can be small or they could be very large. And it's all about the angle measurement that determines what type of angle that it is. If it is less than 90 degrees, we call it acute because it's so small. It's a cute little angle. So we say acute, less than 90. Right, we've talked about, is that perfect 90 degree, and it usually has that box in the corner to show you 90, okay? Right, 90. Then we have obtuse is more than 90. Obtuse. Now, you have to be careful though, because once you hit 180 degrees or a straight line, that is called a straight angle. So an obtuse angle is only above 90, so 91 to 179, any angle within that measure. Once you hit 180 degrees, you're at a straight line. So let's do that jingle together. Acute, less than 90. Right, 90. Obtuse, more than 90, less than 180. That's straight, okay? Acute, less than 90. Right, 90. Obtuse, more than 90. 180 is straight. Very good. Okay, so you will also be talking this week about different types of triangles. So let me move to this poster. Triangles are classified by the lengths of their sides. So an equilateral triangle is equal, hence the word equilateral. That means all sides are equal. Isosceles have two equal sides. And the way I remember that is a lot of times they look like icicles because the two longer sides usually match and then have kind of a smaller bottom, which makes that isosceles or icicle look. Then we have scalene triangles that have absolutely no equal sides. And you might notice on some of your work, these little lines that are drawn on the shapes. If you look at the equilateral, it's showing that all sides are equal by doing one tick mark. The scalene has one tick mark, but then since this line is not equal to those two lines, we note that with two tick marks. Now they both have tick marks because those two sides are equal. So this is showing these two are equal, this one is not. Then when you move to the scalene, you'll notice since no sides are equal, it has a tick mark, two tick marks, and three tick marks because none of those are the same length. Okay. You'll also notice the scalene is also a right triangle, which is also what you're going to be identifying this week. A right triangle is triangles that have one right angle. So if you have a perfect right angle within your triangle, it's automatically a right triangle. So you could say that this is a right scalene triangle. You could identify it in both ways. This is an obtuse. We're not going to worry about this one. The obtuse triangle have one obtuse angle. So if you look at these examples, none of those are obtuse. But acute triangles have three acute angles. So actually, when I look at the equilateral, these are all acute angles. So we would call it an acute equilateral. This also has three acute angles, so I would call it an acute isosceles. Okay. Now I'm going to draw your attention over here because I know you're going to be doing this as well this week. Let me see if I can get it on camera. Okay, angles. Sorry, since I have it on facing me, it's harder to do. Okay, we have the acute angle less than 90, right 90, obtuse more than 90, less than 180. Then we have complementary angles. So this is what you're going to have to start doing this week to find missing angles. Complementary angles means that if there's two angles, since this is a perfect right, these two angles have to add up to 90 degrees. Okay, so 36 plus 54 is 90. Then we have supplementary angles. That is the straight line, and we know that straight lines are 180 degrees. So if I am giving you a straight line, then the sum of the angles have to equal 180. And in this case, 106 and 74 is 180. There's that straight angle. So let me do a couple of those just to show you, because I know that can be a little bit of a challenge. Sorry, let me grab a marker. Okay, so if I am doing a straight supplementary angle, I know that this equals 180 degrees, right? So let's say I have an angle within the angle. And this is acute, this is obtuse. And that's why you need to know your angle shapes, because if you were to get this to be more than 90, you would know you made a mistake. Acute angles are less than 90. Now this, on the other hand, is obtuse. So if you get a degree that is less than 90, you'd know that you made a mistake. Use your knowledge to make sure that you're doing your angle measure correctly. Okay, so since this is an acute angle, I would say let's put this at about 45 degrees. And then I say, well, what's the missing angle, right? So if I know the straight line is 180 and the small acute angle is 45, how are you going to find the missing? Think about it. If the total is 180 and the acute is 45, you have to subtract because we know this plus this equals 180. So using your subtraction, you would have to borrow and you would get an obtuse, good, my answer is more than 90, 135 degrees. Okay? Let me just use this. And if I'm doing a right angle, sorry, not drawn perfectly to scale, and I draw this little acute angle within the right, and I tell you that, which you know both of those would be acute angles, less than 90. If I tell you that this one is 20 degrees, you would do the same thing, except our total this time is 90, okay? So I'm going to take 90 minus 20, and I know you could probably do that in your head, but I want to just show the work, is 70 degrees. Again, it's acute, so it needs to be less than 90. So my missing angle is 70 degrees. How can you check your work? 70 plus 20 gives me a total of a 90-degree right